questions. So we're going to solve this one here. We should be comfortable now with how to draw these, and I can see from my diagram they intersect at 2 points. There's this case over here on the right where it hasn't been reflected, and the case on the left where the graph has been reflected with the modulus. So for the part that hasn't, this is kind of like the positive case where what's inside the modulus, you don't do anything to it. So I'm going to write it like this. So where is that equal? Well, we can add the half, which would give us, that's 6 halves, so that would be 7 over 2x is going to be equal to, if you add the 5, equal to 7. If we multiply by 2 both sides, we're going to get 7x equals 14, so x equals 2. And check with your diagram. X equals 2, yeah, that's actually there already, so oh dear. But that's what we should get. So the larger value is going to be 2, so we're expecting to get 6 over 5 for this other one. How's that going to happen? Well, it's being reflected, so we're going to use the negative case here. So we put the modulus bracket, we change it to a normal bracket, and we put a negative sign in the front. So minus 3x minus 5 equals 2 minus a half x. So what's that going to be? That's going to be 5. I can change the order. 5 minus 3x is equal to this stuff here. What are we going to do then? So let's take away 2 from both sides. So 3 equals, and let's add this 3x. So that's 5 over 2x. So 6 equals 5x. X equals 6 over 5. Okay? And that's what we were expecting for the other one. So these are our intersection points. And we can use that to help us answer this question. So solve the same thing is greater than the same thing. So where's the modulus part? Where's sort of the y? Yeah, the y ordinate higher than that for this one. So it's where it's above, basically. And where is it above? It seems to be above outside of these values. So if I'm sort of looking, if I'm looking over here, or I'm looking over here, the modulus part seems to be greater. So we can say that this is the case when x is greater than 2, or x is less than, what was it, 6/5. Okay? Let's do a couple more very quickly. So solve this one here. And it says there's only one solution. So this is something that you should check by doing a sketch each time. So if we look at our sketch, we have x plus 1 and 2x plus 5. And we can clearly see here where things intersect. So what I'm going to do is I'm going to think, is it the case that it's stayed the same? Is it the positive case? Or is it the case that the modulus has been reflected? Well, I know that x plus 1 normally looks like this, so it must have been reflected. So I'm going to solve with the negative case. Okay, and I will end up here, when I do this, I will end up with an answer of x equals minus 2, which matches what I've got here on the diagram. So the positive case, if you solve the positive case, that's actually not going to be a solution, and you can see it by drawing it. There's no need to make it any more complicated. Next part here, solve where this is less than this. Again, we do the same thing. So what does it look like? It looks like this. And if we put our diagram in, we will see what's going on. Okay. And there seems to be 2 intersection points. So what I would do, if there's 2 intersection points, again, I would investigate the positive case, and I would just investigate the equality first of all. This will lead you, well, I don't actually know what that one will lead, I haven't worked that one out yet, but I would do this one here, and I would do this one here to get my key values. and then come to the inequality at the end. Okay, where is 2x larger? Well, it's going to be larger in this interval here.